So the BeagleBone Black is an open computing platform for makers that's targeting bringing the web to the world. So connecting up the physical world and interacting with things in your environment and using Linux to connect those things up to everything else that you experience. So here we're targeting everybody from first learning how to program. So I just say kindergarten to Kickstarter, right? So if you're just learning to program, you're just starting to play around, or if you're ready to actually go and make something real, make a real product, we try to get out of people's way so there's no barriers to go do that. And we see a lot of people have success. I know there's at least half a dozen projects I've seen around here today. I know there's a couple over here in the corner that'll BeagleBone, the OpenROV, Ninja Blocks, lots of people using them. But basically, it's a 1 gigahertz Linux computer with a lot of features, with USB in, out, and a whole lot of physical interfaces. But the USB and the video out are the main ones that I want to show you today, because you want to do some vision. So this is something that's actually pretty darn easy to get started with. All the tools that you need to start doing the development actually ship with the board. So if you buy a board and you plug it into your computer, you'll actually be able to start developing in 5 minutes. If it's a Windows, Linux, or Mac computer, all the drivers are included right there on the board, so that you don't have to go and search the web to go try to find those things. And also all the things I'm showing you for doing development of the facial recognition, doing object recognition. If you want to do line following with the web camera, or follow red balls, or chase the cat around the house, that's something that all that base software, all the libraries, the C compiler, the make tools are all right there, ready for you. So you can go and follow all the demos and instructions that are out there on the web. So the one I want to point out to you is the face detection algorithm. So this is all done with the OpenCV library. So that is an open source computer vision library. It's a collection of hundreds of different algorithms that can be used to take images and detect objects in them, to manipulate them, and it's a C++ library. And there's a huge set of examples that you can find up on this Willow Garage wiki. So one of them that I've just pulled down is this face detection one. And of course, we can do C and C++ development. They also have Python bindings. And of course, you can do all the development on your Windows PC, your Mac PC, and then move it over to the BeagleBone later. So I mentioned that all the tools that you need ship with it. But the first thing you kind of have to figure out from your computer, this is kind of that first big step, is now I want to actually log into my board and start using that. So I'm going to just show you real simple. If you've got a Mac, I haven't installed anything special here on the Mac, but if I want to go and do that, I can just show you some code here where I'm going to go and log into the board. This USB cable that I'm going to connect up to my board, that actually gets me a network connection. So this acts as a virtual network connection between the boards. I could do the same thing if this thing was out on a Wi-Fi network and I wanted to have a robot drive around, or if I just stuck this out on the Ethernet, I can get that connection. And I use this tool called SSH. You can get that for Windows. It comes with Linux and Mac already. And now I'm actually logged in here on the board itself. So I've got this one example. So I downloaded first Hello World. So the Hello World of OpenCV is this. And if I run it, well, first of all, I'll come back and show you the slides of how to build it. But it's just as simple as going to the Willow Garage wiki page and starting to download and look at all these examples. It's the same way that you'd use development in a desktop environment, but here you're able to take it with you on the go. One thing you do want to point out is if you don't have a monitor connected up to your board, so you can just hook up a keyboard, hook up a mouse, hook up an LCD display. We do have HDMI output on here, so you can just use it like a desktop computer and work with it that exact same way. But but if you want, you could just do that SSH in. You want to use this -X. So that allows me to use the display that's actually here on my Mac instead of using the one on the board. There's also a little hint. If you want to start up a script that runs without you having a login, normally a lot of these graphical applications expect you to be logged in on the board. So if you want to do it remotely, here's this one other little trick that you need to do with this X Authority. And I was mentioning that you need to do the compilation. It's really, really simple because we've got the package config tool that's going to go find all the libraries for you. You don't have to deal with a lot of complications there. So let me show you some more code. So I'm going to actually compile that example now. Switching screens seems to really slow it down. So I need to tell it where the libraries are. I mean, sorry, the header files. And then I just use the package config tool. And then I tell it the name of the application that I want to build, which is helloworld.cxx. And I tell it where to output that. And again, without installing anything extra except for this one Hello World example that I pulled off the web, everything else here is what just what ships with the board. So that's the only thing that I've had to go out and get. And that's all being compiled here directly on the BeagleBone that I have being run off of the USB on my board. And now if I run the Hello World, we can see that I'm actually getting the output now on my own X display. Now if I want to go beyond just the Hello World and I actually want to start doing some vision things, I'm going to have to go out and get a webcam. So for this one portable demo, all I did was go out and get a PlayStation 3i. So this is about a $20 webcam. You can get really cheap just about anywhere. I've also got hooked up here a little bit more expensive one. This is a Logitech C920. But because we're just running Linux and we have a great USB stack, you can just connect up any webcam, and if it works with Linux, it's going to work with the board, and you can go from there. But I'm going to show you working from these. And if I'm going to go back here and run the, so I've switching back and forth really derails this. All right, let me finish the slides first, and I'll go back to the demo at the end. How about that? So I took the face detection application. Well, all right. So in addition, if you want to try to make something that's not just something that's like sitting here connected up to my computer, but actually want a display to go on the go with me, there are a bunch of LCD capes of different sizes, 3-inch, 4-inch, 7-inch. There's even 10-inch displays. Or I connect up an actual HDMI monitor to this, and I can work from that. Let me just kind of give you a little better picture here real quick. So this here is a 3-inch LCD monitor that I've connected up here to the BeagleBone. And this is just running off of a standard USB cell phone charger. So you just need something that's got that 5-volt USB out in order to power the board. And then again, I've got that PlayStation 3i, and now I'm able to actually take stuff on the go. And what I've done here is I've taken the standard face detection algorithm off of the OpenCV website, and I did one little change to it, which is when I detect the face, I actually add a mustache to that. And let me try to show you that working right now. There we go. So there you go. So it's a portable mustache cam, and this is all that was really needed to do this. So I needed to take a graphical image of what I wanted that mustache to look like. I set the region of interest on the face. I've detected the face where I want to apply that mustache to. I scale the mustache image to fit that, and then I apply that mustache right there in the region of interest. And then, of course, I spent a whole lot of time doing some really heavy industrial design work with the, I didn't have an X-Acto knife, so I used a pen. So you can see here my fantastic construction quality here. So this was literally like about a 3-hour project that I did. I actually did half of this in a meeting at work while other people were talking about other things. So I do encourage you to come up afterwards and take a look at yourself in the mustache cam. If you're looking for more information and you want to get the code with the changes applied for the mustache, you can go here to beagleboard.org project stash, and that'll give you all the instructions that you need to kind of gather up and build this yourself. It's a really, really fun project, not too involved. Like I said, you don't even have to go and get this LCD display. You can actually just kind of play with this with just your webcam and your computer. As I'm gonna, believe me, this is easier to work with than the display up to the presentation here. But you can actually use that X display back to your computer. So here, if I want to run stash on my board, there we go. So here it's actually the mustache, the algorithm is all running here on the BeagleBone, but then I'm just remoting the display back onto my computer. So this makes it a really nice way for you to do really quick development before you go and try to spend a lot of time on your heavy industrial design work. So I hope you appreciate that, and please come up and take your pictures with the mustache cam. And we've got some cards that you can take to go find the URL and more information about the boards. They're being sold in the maker shed. And if you see, there's projects everywhere throughout the fair of people doing things with BeagleBone. Please stop and ask them what their experiences were. We really try to keep our community happy, and I hope that you'll join the community. Thank you very much.